Welcome to Every Friday. My name is Michael Olschimke. I'm the CEO of Scalefree. We run a session here every Friday, 11 o'clock Central European Standard Time, to allow you, the audience, to ask questions about data vault, data mining, data-driven applications, MVP clusters, cloud computing, that kind of stuff. You can raise your questions here using the chat in the client or the Q&A function in the client. You can also raise your hand virtually, because I don't see it when you do it in front of the camera, right? So, and I will give you voice. And if we receive multiple questions, we would essentially do cherry picking. Good question is if I can answer it in roughly 10-15 minutes, good enough for online video, right? And if there would be no question at all, I would talk about the cluster here. And at the end of today's session, I will share you a link where you can submit your questions, which is nice. So I can essentially prepare them, which this person did. Well, actually, this is coming from one of the previous sessions on the chat. I saw this at the end, towards the end of the chat. Let me see. So this is about the Delta Lake versus Data Vault. How does Data Vault add value when we have the Data Lake? Now here's the thing. Delta Lake is just a technology for implementing data warehouse systems on the Data Lake, for example, or some, let's say, databases or relations. Let's say relations on a data lake. I had once a question from a CIO, which I know personally. He came to me and said, "Mike, you wrote this book on Data Vault, which is apparently a big data topic. And we have a big data problem because we have this Hadoop initiative. We load all the data from the source systems into our data lake. They used Hadoop back then. And his question was essentially, now we're done with it. What do we do next? What do my users want from me, essentially, right? What do we do with this data on the data lake?" And I said, and that's the same problem you have. What's the value of Data Vault? The question is, what do you want? What your users want? Because at least the users I know, the business users I know, they don't care about data lake. They shouldn't care, or Delta Lake, or some fancy cloud database, or I don't know what else, right? So what they typically care about is business value. And in our space, at least, it's typically reports and dashboards, or in many cases, reports and dashboards. They care about reports and dashboards. That's what they want. Now the challenge what you face is, in for this report or dashboard, they need some information model. Typically, depending on the user, sometimes they can define a information model for you. Typically, facts and dimensions, right? Some star schema, or they at least give you some report or dashboard mockup, and you derive this model for yourself. Essentially, you come up with the dimensions and facts that you need to deliver this information to the dashboard they need, essentially. But somehow they will define it either directly or indirectly. They will define an information model that they need for the information. And now that's a challenge now, because this information model is independent from your data sources. It's defined by the target, right? It's defined by the user, not by the source. In your data lake or Delta Lake, you have essentially the source systems. And a good data lake, in my opinion at least, is organized in a functional way. So for every source system, you have essentially the extract from the source system somehow. It's organized by the model of your data lake is defined, at least in first layer, is defined by the source systems, not by the target. And now you got a gap. You have a gap between the data from the source systems defined or modeled in the source system model defined by the source system, and the information requirement, the information model at the target, which is independent from the source systems. There's a gap in between, right? And this gap, you have to bridge, period, right? You have to fill this gap somehow with some loading procedures from source to target, essentially. That's a problem you face. And if you would tell me what are the business keys in your data set, what are the relationships in your data set, in your source data sets, and what are the descriptive data, I could help you bridge the gap using the loading procedures into HubSync satellites. And then once I have the HubSync satellites, I know how to implement all kinds of business rules on top of that. So I can derive any target model data downstream, what your users want, essentially. But I need to know the business keys in your data set, the relationships, and the descriptive data. That's the basic idea. Once I have those, I can do the rest. So tell me, what are the business keys and so on, right? So, and that's the value of Data Vault. Now you could argue, well, on a data lake, let's say on Databricks, Delta Lake, the performance of the job performance is slow, for example. Yeah, I agree to some extent. The reason is that in a Delta Lake, you use Parquet files down at the lowest level. And Parquet files are column-based storage. And that's why joins are slow. We see this on other database systems as well. It's not a problem of data vault, it's really a problem of the underlying storage mechanism, which is fine. Thing is this. We said we have some information model, what you have to deliver. That's what the users want from you, right? They don't care for the data in between. As bad as it sounds to me, for me personally, that's what it is. They don't care for the data in between. They don't care for the data lake and so on. They just don't care. They just care for the end result. And performance-wise, if I would be a user, I would expect that my queries with my dashboard or my custom queries against your data sets, those are fast. How you get to the result, I don't care. Which means that for the information marks, the targets that we define, you have to achieve high query performance. That's for sure. And if joins are slow, what I would do is I would denormalize everything. So I wouldn't use a star schema. I would use a fully denormalized fact view or fact table, let's say, fact entity. A fact entity where every dimension attribute is denormalized into the facts. Because then I don't need to join anything anymore, and that query performance is fast. That's what I know for sure. Then I would use Parquet files, maybe delta tables, and so on. That's what I would use. And so my target is clear. I don't need a star schema. I would prefer a flat and white table, everything denormalized inside this fact entity. That's my target. And how you get there, I don't care. One option would be data vault. Break it apart, the incoming data set, break it apart into business keys, relationships, distributed data, maybe in a data vault design, hubs and satellites. Could be delta tables, right? So just have it on the as a delta table, for example, in Databricks. And then attach business logic in views, for example, and so on, to produce the final Parquet file, which is materialized, where nobody cares about performance anymore. Well, they do, but it's fast. And yes, there might be a performance impact in the worst case. There might be a performance impact in the raw data vault or business vault when you join all of it together. But you do it overnight. If it's slow, scale up. Right? That's one thing. So you could just fix it by scaling up, at least for a while. That's number one. We can even get this done better. So there's some ideas that, first of all, you don't need to materialize everything in the raw data vault here. You could also virtualize the satellites, for example. Keep the hubs and links. They maintain your granularities, but the satellites can be virtualized, for example. So there's some tricks how we deal with these performance issues in a data vault design on a Delta Lake, but we can deal with this. It's a tool, right? It's just a tool to come up with your Parquet files at the end. That's the basic idea. So that's number one. And then that's how I think about this. Again, it's really about managing data flows. You have an incoming data flow from the source systems, or multiple incoming data flows from the source systems. That's your staging or landing zone area in your data lake. And then you have the target to be produced as an information mark from the data warehouse or data vault 2.0 architecture. And then in between, we use the data vault design, the data vault model, to deal with your super large data flows, break them apart into much smaller data flows, so they're easier to manage, easier to transform. And then I can, from all these little small data flows, hubs, links, satellites, I can then join them together to form my target. So I'm using data vault in the architecture as a tool to creatively destruct the source data sets and turn them into what the users want. That's why it is. I'm not producing a data vault model for consumption because they don't care. They just want to have star schemas or flat and white schemas. They want to have reports and dashboards. That's what they actually want, reports and dashboards. They don't even care for star schemas and snowflake schemas. They want performant dashboards and reports. That's what I want. So that's one thing. And then when you look at the Delta Lake, what we often see is that people struggle with this to some extent as well. So the Delta Lake captures changes on the record. So let's say you receive data from the source system and you capture the changes as deltas, one way or the other. I mean, you could just offload the data from the source as Parquet files, create an external table on top of it. I'm not sure if I would use, if you go fully incremental, into only incremental, there are no updates, there are no deletes. Well, there might be some deletes, but we have to really do the delete and not just capture this as a soft delete. So for the landing zone, to be honest, I would just use external tables on top of Parquet files that I manage, or Avro files that I manage. I'm not sure if Avro files works, Parquet files. So you would use external tables or foreign tables on top of the Parquet files that you upload to your landing zone area in your data lake. And then For the raw data vault, I still keep insert only and incremental, so I don't update anything, right? Well, we could have a managed table, a delta table, for example, or iceberg table, whatever. We could use that for hubs and links and maintain it using insert statements, fine. And then for the satellites, here's the thing. If you compare the delta check in a satellite compared to the delta in the landing zone area of your data warehouse or data platform data lake, there is a delta in the landing zone whenever there's a change in a source data set. So when a row changes, let's say you have a customer record and the first name changes, you get a new delta, right? Well, the delta check in a satellite is much more efficient because typically we split a satellite. We have one satellite for the personal attributes, one for non-personal attributes, one for different security classes, and so on. So typically the customer data is loaded across or into multiple target satellites for optimization, security, privacy, rate of change, and so on. And this one change in the source data set, this one column, the first name that has modified, has an impact on the landing zone table. So there's one new row with the latest version of the customer. But this one change only affects one of the satellites in a raw data vault, right? The satellite where you capture the first name. The other stuff, I don't care. The other satellites don't care for this change. So when you think about this, the delta check or the delta capturing in the satellites is more efficient because it uses less storage. And now people struggle now with turning the deltas in the landing zone, in this delta-driven staging area, whatever, into the raw data vault satellite deltas. They struggle with that. Honestly, what I would do is, again, have hubs links materialize as iceberg tables, delta tables, and then the satellites, I said hubs links, yeah. So the satellites, what about having them as views on top of the staging data? Just a view. Yes, I agree. There will be lots of non-deltas because now all your satellites, for the first names, last names, but also for the address and so on, all these satellites will now all of a sudden have one delta for every incoming change from the source, even though it should not affect this one satellite because this attribute is not there. The first name is not in the target satellite, but still a delta because I just create a view on top and turn off the delta check. With the argumentation, yes, first of all, the delta in a raw level satellite would be more efficient, but honestly, not that much more efficient. So yes, you would gain a bit, but for the effort to reduce the delta now to the actual satellite delta, the effort is not worth it. And honestly, you already saved the data in a landing zone / staging area. It's already saved. So by materializing the deltas in the target satellite, you're adding additional storage. If it's a view, you're not adding any storage. So it's actually more efficient storage-wise. We're not adding more storage. I agree with the queries. You would query less data. Okay, so it would be more efficient queries downstream. I agree, but not worth the effort. Because in all honesty, yes, I agree. So this one first color, the first name that you just got modified would only affect one of your 10 satellites. But yeah, you only get delta, so you don't get full loads every day. So it's not that you're reloading a record for millions of customers into all the satellites all time. Only when there's a change. So it's relatively efficient already, right? So we can live with that. So just create a view on top of your staging area, present it as a satellite, and that gives you, again, your structure. Because I just need to use Data Vault as a tool here to, in the next step, attach the business vault entities and then produce the packet file again. And I'm trying to be as efficient as possible, essentially. So those ideas you'd use to implement the system depends a bit on your actual architecture, your actual tool stack, and so on. So I have no 100% direct answer here how to implement this on a Delta Lake, but consider Data Vault as a tool to produce your target. And that's typically a flat and wide fact entity to prevent any joins downstream. And I would try to reduce satellite splits. Security, you don't have to implement as a physical satellite split, depending again on the tool stack and the tools you use. But yeah, so that's it. Those are the ideas that you want to think about. And that's the value. The value here is of Data Vault is a tool to produce your targets. That's the idea. Peggy, 1 second. I'll give you a voice. I can find the button.
Hi, Michael. Thank you. Thank you. I was just looking for the chat to say that's very interesting. Thank you. I don't really have a question.
It's on the spot. So I believe it's your question. It's on the spot.
Oh, yes, thank you.
Cool. Okay. So those are my thoughts essentially. How we implement how we use Data Vault on a Databricks installation. The argument, you see a lot of articles where they say, well, data was not good for Databricks because of join performance. Yeah, well, first of all, it's because of the Parquet files and the underlying Parquet files is number one. That's why the join performance is bad. The other thing is, I would argue in many cases, do we need delta tables or iceberg tables because we just do inserts and that's it, right? So if an insert into insert only strategy and increment strategy, so we don't need the capabilities of updates and deletes and that kind of stuff. So you could argue on that one. So you could even argue with dealing with these, or you maintain these Parquet files by yourself, and then just work with external tables, for example, right? So those are the ideas floating around in how we implement the Data Vault on Databricks. Don't believe everything that's written on the internet, right? So that's what it is. Okay, and it works. So performance-wise, the end users care about the target, not about everything in between. That's the idea. Okay, cool. So yeah, it's a good question. I saw it on a chat and it was too late to answer it essentially. And it was too long. So I knew I have to explain this a bit. Cool. I didn't use the whiteboard though, so be it. So if you have a question like this, use this form here. sfr.ee/EV Friday. That's where you can submit your questions. Gives me some time to prep the slide essentially. And we also have other additional webinars at scalefree.to/webinars. That's where you find webinars on RESTscape and DBT, for example. Where you can also log in and talk to the tool expert at Scalefree, because I'm not a tool expert. And if you can't wait until next Friday, and the webinars, the other webinars are once a month. If you can't wait for that, check out the Data Innovators Exchange. That's where you can also, and it's a forum-style community where you can ask questions, and there's a little competition going on between Initial Data and Scalefree. Initial Data is in Australia, Scalefree in Europe, and the goal is to answer this question as quick as possible. And the Scalefree guys going to Australia these days. Longer story. They want there's a couple of people from Scalefree going to Australia, a couple of people from Initial Data from Australia coming to Europe, Germany. Yeah, use this one and submit your questions for next week, essentially next Friday. I'll not be there because I'm traveling for business. But somebody from Scalefree will jump in and will be a good replacement for me, that's for sure. See you guys in 2 weeks from now, and enjoy next week's session. So we'll be there. Thank you guys.
Bye.